Alright, this is Mr. Gillum, and today we're going to learn how to solve one-step equations using reciprocals. And so um, we will use reciprocals or inverses on specific type of one-step equations. First things first, let's do a little reviewing. We've talked about the inverse property of multiplication before, and the inverse property of multiplication says that if you have a fraction and it's reciprocal, and you multiply them, their product will be 1. And so maybe you don't remember what a reciprocal is, but let's do a quick example of a reciprocal. If I knew that 2/3 was my fraction, its reciprocal, or its inverse, those two words can be interchangeable, would be 3/2. And the reciprocal of 3/4 would be 4/3. And as you can see, the numerator and the denominator, the top and the bottom of the fraction, have just changed places. We call those inverses. It's inverted, or a reciprocal is a fancy name for it. Or if we had 5/6 and 6/5, those would be inverses, or reciprocals. Or 7/8 and 8/7, also inverses, or reciprocals. So I might use the word reciprocal or inverse, but I just want you to keep in mind that those mean the same thing. Okay, it's just when you flip the fraction, the numerator becomes the denominator becomes the numerator, the top and the bottom trade places. Now the inverse property of multiplication says that if you have these inverses, and you notice that the fractions are exactly the same except for that the top and bottom are switched around, then you can multiply them together and it'll equal 1 every time. Okay, the product is always 1. And so let's take a look at these inverses, and we're going to go ahead and multiply them. And this is a good time to review how to multiply fractions as well. Remember, multiplying fractions, we're going to check the top and the bottom of the equation for reducing. Then we're going to check diagonally to reduce. And I know that 2 and 2 will go into 2 one time, and 3 and 3 goes into 3 one time. And as you can see, everything has reduced, and when I multiply straight across, 1 divided by 1 is the same as 1. And so the inverse property of multiplication holds true. It just equals 1. And so let's take a look at this one down here. Again, I'm going to check above and below. 3 and 4, nothing to reduce. 4 and 3, nothing to reduce. Now let's check diagonally. 3 and 3 both reduce by a factor of 3. 3 goes into 3 one time, as does 4 go into 4 one time. And as you can see again, then if I was multiplying these two inverses or reciprocals, it would equal 1 over 1, which is the same as 1. 5/6, same way, reduce, reduce, cross reduce, cross reduce. And again, you get 1 over 1, which is really 1. Or 7/8, reduce, reduce, cross reduce, cross reduce. And again, we get 1. And so this holds true for any inverses or reciprocals. When you multiply them, it equals 1. And so we're going to use this strategy here in a second to help us to solve these one-step equations. Now, sometimes students get upset that they see the fraction in the equation because it bothers them because they just don't like the way it looks. They're confused about fractions sometimes. But instead of turning these equations today into two-step equations, we're going to use what we know about the inverse property of multiplication to solve these equations. I know that I can think of this equation a lot of different ways. All right. One of the ways I can think about it is that I have 1/3 of an x. So I have, if this is an x, I have 1/3 of it. Okay, and I know that equals to 2. So if I thought of it like a balance, if I wanted another third of the x on there, then I'd have to add another 2. And if I had to add another third on the x, I'd have to add another 2. And so I know that the whole x would equal 6. All right, that's one way I could think about it, and I could solve it with the algebra blocks that we've been using. Another way I could think of it is as a one-step equation, and we're going to use algebra to solve it. And so that's great that you can solve it that way in your head, or maybe with the model, but I also want you to know how to do it algebraically. So we're going to use what we learned about inverses to help us solve this one-step equation. And the problem in this case is that we have this 1/3 here in front of this x, and it's being multiplied. And when you see the fractions, it's a little different. I know that we said the inverse operations, we would do the inverse operation of multiplication would be division, but when we divide both sides by 1/3, that's going to get really messy. So we're going to take an alternate approach instead. Okay, we're not just going to divide both sides by 1/3. What we're going to do is we're going to multiply by the reciprocal and use the inverse property of multiplication. And so I know that the inverse of 1/3 is 3/1. So I'm going to put both sides in parentheses, whatever's on the other side. It might be more than one thing. And I'm going to multiply both sides by 3/1, which is also known as 3. Now notice when I wrote this on the right-hand side, and I've been doing these equations a long time, that I put the 3 on the same line as the 2, and I put the 1 on like the next line down, because when I multiply fractions, I always want to keep them as over 1. But I want to always make sure that I know which numbers I'm multiplying so that doesn't get confusing for myself. So let's do this left-hand side first. I know through the inverse property of multiplication that if I multiply by the reciprocal, I'm going to get a result of 1. I did it a lot of times with a lot of different equations or fractions, and I got the same thing every time. So this is no different. I see that I will get nothing but 1x. Okay, so now I have a 1x, and on the right-hand side, this is really the same thing as saying 2 times 3. In this case, would be 6. And 1x is the same as x. We didn't write the 1 in front of it, so I know that x would equal 6, which is the same solution we got when we modeled it. All right, so let's take a look at the next one here. 1/5 x equals 3, and again, we could think of it like this. If I had the x on the scale, and I had on the other side it was balanced with a 3, and it was only one of the 5 pieces. If I wanted another one of those 5 pieces, I'd have to have a balance of 3 more, 3 more, 3 more, 3 more, until I finally had a whole x. I would know that was equal to 1, 2, 3, 4, 5 times 3 is 15. Okay, and so that's one way you could think of this equation, but they're not always going to be that simple. In fact, I'm going to show you a few that aren't that simple now, and that's why the algebra is so important. I'm going to use my new strategy that I learned, and I know that instead of dividing both sides, even though it is held together with multiplication, instead of dividing both sides by 1/5, that's going to be really nasty to try to do. And so I'm going to take a new approach, and I'm going to use what I know about reciprocals to solve this equation. I know that 1/5, its reciprocal would be 5/1. And so I'm going to multiply both sides by 5/1. And put the 3/1 when I'm multiplying fractions. You can also think of 5/1 as just being 5 and take away the fraction instead. In fact, that's what I'm going to do this time. Now reciprocals, when we multiply them, always equal 1, which is very, very, very helpful. And so altogether I just have 1x or x. Okay, 1x, or really I have x. And on the right hand side I have 15, which is the same solution we had when we modeled it. All right, so let's use algebra and inverses again for these problems. I'm going to try to model this one, but you're going to see very quickly that it's a little more complicated when there's 2/3 of an x. If there's 2/3 of an x, and I have a 1 over here, uh-oh. If I add a third here, it's hard to know what to add over there. I would have to add a 1/2. But things get complicated very quickly when the fractions change and there's numerators involved. And so modeling might not be the best way to solve this question. So algebra, on the other hand, will be a great way to model the solution. So I see that the only thing over here with the x is this 2/3, and I know that inverses, when multiplied, make 1, which is very important. So I'm going to put both sides in parentheses. I'm going to multiply both sides by the inverse, or the reciprocal, of 2/3. Which is in this case 3/2. I know that when I multiply inverses, they always equal 1, and that's why I'm doing that. That's the whole strategy, is to get rid of those fractions, those nasty fractions. And so I just have 1x left over, or just x. On the right hand side, I know anything times 1 is itself, so I will still have 3/2. You don't even have to change it to a mixed number. You may just leave it as an improper fraction today. All right, and again, if I tried to model this one with this 4/5, it's going to be kind of tricky. So I'm going to use what I know about inverse fractions, I'm going to multiply both sides by the reciprocal of 4/5. And so I'm going to multiply by 5 over 4. Things got a little trickier here, so I'm going to go ahead and make this fraction over 1. Now, the nice part about this is that I know that x will be all by himself because 5's can reduce, 4's can reduce, and all I'm left with is 1x, or what we know as x. On the right-hand side, though, oh man, I got to actually multiply these fractions together. So I'm going to look. Does 7 and 1 reduce at all? No. Does 5 and 4 reduce at all? No. Now I'm looking sideways. What about 7 and 4? Do they reduce? No, they don't reduce. Or 1 and 5? No, they don't reduce. So now all I'll do is multiply straight across. 7 times 5 is 35. And 1 times 4 is 4. Now that would have been a crazy fraction to try to get on your model. So that's why we have to use other techniques sometimes, like algebra. Let's take a look at these last two here. And again, I have, the problem's got a little harder. There's fractions on both sides. And so it might be confusing to know which reciprocal to multiply both sides by. Just keep in mind, when we're solving equations, we always want the variable all alone. And we don't really care what's on the other side, but we're just trying to get x, in this case, all by himself. And so I'm looking at this fraction of 3/4 when I'm deciding which reciprocal to use, because I want that 3/4 to be 1. So we would have 1x. And it's all just like a puzzle that we're trying to solve. So if the objective is to get x all alone, I want to multiply by the reciprocal of the number in front of x. In this case, the inverse or reciprocal would be 4/3. I just flip over the fraction. On the right-hand side, I also have to keep it balanced, so we have to multiply that side as well. That would be an easy part to forget. I love multiplying inverses because I know the result is always 1, and that information is going to be very, very useful for us. And that just gets x all alone, which was the whole point. Unfortunately, we have a little cleaning up to do on the right-hand side. So I'm going to look at 5 and 2. There's nothing to reduce on that part. And 4 and 3, I don't see anything to reduce there. Sideways or diagonally, 5 and 3. Do they reduce? No, they don't. 2 and 4 do reduce though. 2 can go into 2 once and into 4 twice. Now what's left to do is multiply straight across. 5 times 2 is 10, and 1 times 3 is 3. 10/3 will be my solution. So although we have a little bit of multiplication of fractions to do, these aren't too bad because of what we call the inverse property of multiplication. Let's take another look here. This one says 2/3 x equals 5/6. Although there's 5/6 here, we can just ignore him for now because really we just want to get rid of this 2/3 over here. And yes, I understand that the 2/3 is being multiplied by the x, but if you wanted to divide both sides by 2/3, that's going to get kind of gross and nasty. And so an alternative approach would be to multiply by the reciprocal. Okay, it's just making your life a little easier. And so, because I'm trying to get that x all alone, I'm going to multiply by the reciprocal of the fraction in front of the x, 3/2 in this case. And the nice thing, like we said, was that the reciprocal will eliminate all that fraction stuff around the x. Unfortunately, on the right-hand side of the equation this time, we do have to multiply these fractions together. We'll reduce 5 and 6, 3 and 2, cross-reduce 5 and 2, 6 and 3. Oh, that will reduce. 3 goes into 3 once and into 6 twice. And now I think I've reduced everything. 5 times 1 is 5. 2 times 2 is 4. So x equals 5/4. So again, this can be a confusing lesson, but it all goes back to the property of the multiplication property of inverse property of multiplication, which says that if you multiply reciprocals or inverses, the result or the product will be 1. And that's the big point for today. Okay, so we're going to use that to help us strategize in solving our equations.